We're going to start by factoring by taking out a GCF. And factoring is all about division. So the question is, what can I divide both of these terms by? If you look, you'll notice that there's a 5 in both of them that I can divide both of them by, but there's nothing greater than a 5. So 5 is my GCF, and then when I divide each of the terms by 5, I get a minus 7. So that's how you factor by removing a GCF. We use that same concept to help us factor quadnomials or polynomials with 4 terms. But since there's so much going on here, and if you notice there's no one thing that I can divide all 4 terms by, what I do is I break it up into pieces or groups. So my first group is going to be the k times m plus 7k. And my second group is going to be the 2m plus 14. And so what I'm going to do is I'm going to look for a GCF of each of the 2 groups. My GCF for the k times m plus 7k, if you notice, I can divide both of those terms by k. So I write k as the GCF, and then inside the parentheses, I write what I get when I divide both terms by k. So I'm going to get an m plus 7. Then I need to do the same thing with the 2m plus 14. Notice that I can divide both of those terms by 2, and when I divide both of those terms by 2, I get m plus 7. Also notice that this is a positive 2, and that the sign between the 2 groups was positive. So I've got a positive 2 there. Now we can look at the entire problem and notice that both of these new terms, which is what we have now, we have one term here in green and a second term here in blue. And both of those new terms can be divided by a factor of m plus 7. So if I remove the m plus 7 from both of the terms by dividing by m plus 7, I have k plus 2. So essentially, our 2 factors are made up of what was inside of both of the parentheses and by what was outside of each of the parentheses. So the k plus 2 came from the insides or the outsides, while the m plus 7 came from the insides. If you were to multiply this back together, and remember, you can always check your factoring work or your division by multiplying, which is the inverse operation. So if I were to check this, notice that I would get an m times k, and then a 2 times m, then a 7 times k, and a 7 times 2. And while these terms are in different orders, you can use the commutative property of multiplication to rearrange m times k as k times m, and you can use the commutative property of addition to rearrange 2m plus 7k to be 7k plus 2m. So we have what we started with, and we know that we did this problem correctly. For this problem, if you notice, we don't have 4 terms. We also do not have a GCF that we can divide these 2 terms by. So in order to get 4 terms, or to find a GCF and then factor by grouping, we need to find a couple of numbers that will multiply to give me the C value, or the last term here, and add to give me the B value. If you notice, there is no B value written in this problem, which means that we're looking for 2 numbers that add together to give us 0. And if you think about it, negative 1 times 1 are the only 2 integers that multiply to give you negative 1, and they also add to give you 0. So I can write a negative 1x plus 1x, And those do add together to give me 0, so I haven't changed what I started with. I just rewrote 0 in a different way. So now that I've done that, I can use the same method I used for the previous problem and factor by grouping. In these first two terms, the GCF is an x, and when I divide both terms by x, I get x minus 1. In the second two terms, I can divide both of the two terms by 1, and that's the only thing I can divide them by. And when I do that, I am left with an x minus 1. So, if you notice, we have an x minus 1 in both of the two terms. And when we divide both of the terms by x minus 1, we are left with an x plus 1. Now you may remember from class that we have another method for factoring what we call a difference of squares. We can factor a difference of squares by noticing what is squared first, the x, and what is squared second, the 1, writing both of those numbers in two sets of parentheses and then including a plus in one and a minus in the other. So that's two different ways to solve those. Now what if we have a trinomial instead of a binomial or a polynomial with 4 terms? Now we need to try to make 4 terms out of 3 terms. And so the procedure for this is to keep the same term that you have first and keep the same term that you have last. And then for the middle term, you're going to break that up into 2 terms. Both of them will be like terms with the middle term, so both of them will have an a in them. But to figure out what the coefficients of those two a's are, you're going to multiply the beginning term times the end term, and in this case we have a 1a squared times a negative 27. So when we multiply those together, we get negative 27a squared. So we're trying to find two values that multiply together to give us negative 27a squared. And they have to add together to give us 6a. So, to do this, the main thing that I consider is the numerical portions of these terms. So what two numbers multiply together to give us negative 27 and also add together to give us 6? If you think about it for a little while, you'll probably come up with a positive 9 and a negative 3. So positive 9a times negative 3a is negative 27a, which is what we were supposed to get when we multiply. And positive 9a plus negative 3a is 6a when we add those together. So I can put a 9 as a coefficient of the first a and a negative 3 as the coefficient of the second a. I could also switch those two. It doesn't matter which order you write them in. And now you see that we have a 4-term polynomial, which we can then solve by factoring with grouping. So here's our first group, GCF of a, and when we divide both terms by a, we get a plus 9. And then our second group is the minus 3a and the minus 27. Now if there's a negative or a minus sign in between your two groups, you're always going to have a minus sign in between your two terms when you do factoring by grouping. So also we can divide both terms by a 3, that would be the GCF. And when we go into both of these terms and divide them by negative 3, we get a positive a and a positive 9. Now notice once again that we have the same factor in both of these two terms, and that's the a plus 9. So that will be the GCF of these two terms. And when I divide both terms by a plus 9, I am left with an a minus 3. So we've factored this cubic trinomial into the sum or the product of two binomials. Notice also that the two numbers that we used in our multiply and add chart, I'll try to use a different color here. The 9 matches the 9 here, and the negative 3 matches the negative 3 here. And that will work only when you had a coefficient of 1 on your squared term there. We have one more example to do. And that's to see what happens when the leading coefficient is no longer a 1. So same procedure here, we're going to multiply the leading coefficient, the 3, times the constant term, which is the 8. And when we multiply these together, we are going to get a 24w squared. But we're also going to be adding to get the middle term, because we want to break that middle term up into two separate terms that combine to give us a negative 10w. So we're adding to get negative 10w. So if you think through all the different terms, or all the different values that will multiply together to give you a product of 24w squared, there are values that are both positive and values that are both negative, because numbers with the same sign multiply to give you positive values. So if I multiply a negative 6w and a negative 4w together, I'm going to get a positive 24w squared, and when I add them I get a negative 10w. So I'm going to break up the 10w in this problem into a 6w that's negative and a negative 4w. And I'm going to leave the first and last terms exactly as they are, just like I did in the previous problem. So the only trick to these is making sure that you do multiply the beginning and the end, and then you can factor by grouping. In the first group, notice that our GCF is a combination of a number and a variable. 3w can be divided into both of those terms, and when I divide both of those terms by 3w, I get a w minus 2. Notice again in this one I do have a negative sign between my two groups, so that's going to be in between my two terms here. And in addition to the negative, a 4 is a GCF of these two terms. So when I divide both terms by negative 4, I get w and minus 2. And once again, we do have the same factor for both of our terms, and that is our w minus 2. So that's going to be one of the factors of our original trinomial. And the other factor will come from the GCFs from both groups. So we'll have the 3w and the minus 4. And once again, you can check these by multiplying them back together to make sure that they do in fact give you 3w squared minus 10w plus 8. So that's how you factor trinomials, binomials, which are a difference of squares, and quadnomials, or four-term polynomials, by grouping.